Hello class, in this week's lab we'll begin to learn about hypothesis testing. This is a continuation of inferential statistics. Last week we learned how to calculate confidence intervals by hand and in SPSS for proportions and means. This week we'll learn how to conduct a hypothesis test. And the concepts that you learned for confidence intervals and standard error and dealing with sampling distributions are going to become important now to be able to understand the results of a hypothesis test, which will begin shortly. First, we're going to review confidence intervals, which we did last time. You see on the left side here, I have the lab file for this exercise opened on the left side, the PDF, and on the right side I have opened the data set. This is the North Carolina birth data. We've worked with this data set a few times. This is the random sample of 800 mothers from 2001. There's a short description at the top of the lab file. If you recall, last time in the confidence interval lab we learned how to get a measure of the precision of our point estimate, which we call our confidence interval. We have a point estimate of the population parameter, which is, for in this example, we were interested in smoking prevalence during pregnancy. From our sample, we have our point estimate of 14%. So 14% of mothers in our sample smoked while they were pregnant. That is our estimate of the population parameter. That is the population from which our sample came. We would like to have a measure of the precision of that estimate, which is our confidence interval. Now in SPSS, to obtain that confidence interval, if you recall, we go to our Analyze menu, Descriptives, Explore, and the variable we're interested in is smoking during pregnancy. So in our variable list here on the left side, we're going to move that under the area dependent list. Now the second option, we're going to, if you recall, I had mentioned that as the semester progresses, we'll learn how to use these options more and more. So right now, what you would be doing to adjust your confidence interval, if you wanted to, you could click on the statistics option, and by default our confidence interval is set at 95, which is fine for us. But if you did want to change that, you could change it if you like, depending on how precise you want it to be. But for this exercise, we're going to leave it at 95% confidence interval, and for most cases we'll be calculating 95% confidence intervals. But just know that you could change that if you needed to. And we're going to click continue, so everything looks good so far. We're just going to need statistics in this case. We don't need any plots. We can now just click on OK to get our output here. So what you see here is a value, a point estimate here of 14%, 0.14, and our confidence interval 0.12 to 0.17. This is exactly what we did last week. This is just a review of that. And our hand calculations are on the next page. For our hand calculations, we first need our value for a point estimate here, which we obtained from a frequency table in SPSS. Those directions are here. Hopefully we all definitely would know how to do that by now. So we have our point estimate. The second thing we need to do is get a value for our standard error, which you recall is the term we use for standard deviation of the sampling distribution. So our our sampling distribution, which we are assuming to be normal because of the rule of thumb which we learned to use. If you recall, the rule of thumb that we learned to use NP and N times 1 minus P, both should be greater than 15 to assume a normal sampling distribution. Otherwise, we'll be doing the exact binomial test. We may have time to get into that later, but for most cases we'll assume a normal sampling distribution by checking this assumption. And in most cases this assumption will be met. We will maybe get into cases where that assumption is not met. So for this case we see that NP and N times 1 minus P are both greater than 15, so we assume a normal sampling distribution. And we have our value for standard error here, which is 0.012, and we learned this equation last week. This is how we calculate our standard error. And we need our standard error, and we need our point estimate, and we need our, you see here, 1.96, which is our z-score from the standard normal distribution. This z-score, if you recall, depends on our confidence interval. So in this case, for a 95% confidence interval, we're using a z-score of 1.96. If it was 99 or anything else, our z-score would change. You should all know that by now. We know why we're using 1.96. It's because we're calculating a 95% confidence interval. So we have our point estimate, and we're plus minus our margin of error here, which we calculate 1.96 times our standard error. And we see our confidence interval 0.12 to 0.17, which is consistent with what we obtained from SPSS. And here is an interpretation of that confidence interval. We can be 95% confident that the proportion of women in North Carolina who smoke while pregnant falls between 0.12 and 0.17. So last week we learned a little more detailed interpretation of confidence intervals and what exactly they mean. Taking 95 samples out of 100 would contain the true population parameter. The confidence intervals would contain about 95% if we were to take repeated samples from the population and calculate a confidence interval for each. About 95% of those confidence intervals would contain the true population parameter. So if you need to review those concepts for confidence intervals, you can look at the lab from last time. So far this is all review, and next we're going to move on to doing a hypothesis test, and we'll get into that next.